and turn on captions. And we're going to start with chapter 1. And I'm going to go to the actual textbook. So if you've got a textbook, you're welcome to pull up the textbook. If you have your laptops, go ahead and pull up the laptops and pull up your e-text. Now, let me go ahead and warn everybody that the first 2 chapters are reading. So I don't want you to fall in a false sense of security by saying, oh, I can take this class. It is going to get more difficult. Okay? All right. So those of you that think you know everything, it's going to get more difficult. Mr. McDonald, make sure you mute your the only one I don't want muted is the classroom, because I have to listen to the classroom. Okay. All right. So let's pull up section 1.1 in the e-text. And those of you that have a book, go ahead and turn to 1.1. I'm going to hit the highlights of 1.1. And I will tell you, well, let me get out of this. I will tell you that some of the definitions that I go over, I do not test you on. I will tell you which ones I don't test you on. So, like I said before, it's pretty difficult to fail my class. It's real difficult. All right, so my lab's math. I'm having to pull the book up again. I'm sorry. So give me a second. And Math 1 2023. And the ebook. And 1.1. And I'm going to blow this up because, and you might want to turn off the front lights in the room if you can, so that the board will show up better, because I want my guys on the back row to be able to see everything. So here is the actual book, and there is the chapter 1.1. And let's write down the first word, and that is statistics with a capital S. Now, you don't have to see the fine print, because I'm going to give you my definition, and then you can read over the definition and see which one you like. The definition of statistics with a capital S means, and here it comes, the collection, calculation, and interpretation of data. And that means I'm going to pull this up, and right up under there, I'm going to put capital S, statistics, means the collection, calculation, and interpretation of data. The collection, calculation, and interpretation of data. Now, notice that it is started with a capital letter. This is very important because you are tested on this. A lowercase word, statistic, and an uppercase word, statistic, is not the same thing. Can anybody tell me what lowercase statistic means?
A numerical summary of a sample.
It's a variable of the sample, exactly. The uppercase statistic and the lowercase statistic has 2 separate meanings. And I put that on the test, and out of 30 students, I'll have 5 or 6 people miss it. So do not miss it. Let's go ahead and write down lowercase statistics. It's not on the book, so I'm going to write it right here. Lowercase statistic variable used in sample calculations / formulas or equations, if you want to say equations. And it usually is an alphabetic letter. Okay? Lowercase statistic is a variable used in the sample calculations or formulas using an alphabetic letter like A, B, C, D, E, F, G, all the way to Z. Example, the Z score is equal to, the Z for the sample is equal to X minus X bar over standard deviation. Now, if you were given this in a meeting or a presentation after you finish college and you're sitting in a report or you're sitting in a meeting and you see this, you automatically know that it is the sample because you've got alphabetic letters. Capiche? So, speaking of the sample, what is the sample? Sample is the smallest group. The biggest group is called the what? The population. No sneezing in class. Bless you. We had a teacher one time, got fired, of course, that would throw you out if you coughed more than 3 times, yawned more than 3 times, or sneezed more than 3 times. And you could, that could be one of each. If you had 3, one of each, then that means you got thrown out of class. She was fired before the semester was over. Some of these teachers aren't very bright. Population is the big group. Sample is the small group. Now, I teach you in layman's terms. You go back and read the book if you want sophisticated terms. But I found that teaching students with simple terms helps, and then they can add on the fluff and the raise your pinky up. You can do that by reading after you understand what we're doing. Population is the big group. The formulas that you use will be made up of parameters. Parameters are Greek letters. And this is the easy questions on the test that people miss. There is a question on the test that says, find the average or the mean of the population. And it's like 5 numbers. And then you have a choice to pick between A and B. A says X bar, and B says mu, which is the correct answer if you're doing it for the sample. X bar, because it's an alphabetic letter. The Greek letter is for the population. I need you to make sure you understand that. I'm going to give you an example right now. The z-score for the population is equal to x minus mu over sigma. That means you are dealing with the population. Population parameter. Remember this because this is a test question. For, let's see, I can't remember how many's in the group. Hold on a minute. Well, my mouse is, let's see how many's in this group. For the 10 people that are actually listening, this is a test question. And the population, capital P, and parameter, they go together. Sample, we have already specified that for the formulas in a sample, you're talking about statistic. And that means Z of the sample is equal to X minus X bar over S. And therefore, you know that you're dealing with the sample. So sample goes with lowercase statistic. Now that is 2 or 3 questions right there that 10 of y'all will get right and about 5 of y'all will get wrong on the test. And the other question is capital statistic. So there's one question and there's 2 questions right there. We'll get into the formulas later. You don't have to worry about the formulas. I'm just trying to show you why it's important for you to know the difference between a population parameter and a sample statistic. Any questions from the class? Because the virtual people, they can raise their hand, virtual hand, if they need to. Okay, so let's move on. I've just given you 3 questions right there. And on the next page is probably where they're going to go over all of that. Well, maybe on the next page. There we go. So if you want to write down page 5 is what I just went over. Now make sure you write down descriptive. Now I'm going to give you the definition of descriptive, and you can write it down or you can write down what's in the book. Descriptive statistics is when you find your test average. All of you have been finding your test average since the 6th or 7th grade, since you've learned how to do it. Somebody tell me how you find your test average. That means I want somebody to say something.
Okay, so how many questions there are? You divide it by 100, and then how many you got right, you multiply it.
Exactly. Now, tell me this. If you make a 78 for your test average, does that mean that you're going to make a C for the semester if you've got 3 more tests left? Yes or no?
No.
No. So the descriptive statistic only tells you one thing. It tells you the average or the standard deviation, but it does not what? It does not predict. The descriptive statistic will, it'll find the average, the mean, the standard deviation, the mode, the mid-range, all of that stuff. But it doesn't what? It doesn't predict. And usually it's your own data. can I take Miss Wiles's grades and average them together and predict that she's going to fail or make an A this semester and she's got 4 tests left? No, no way. You can't predict using descriptive statistics. What can you predict with? Inferential. Inferential, because you infer. Inferential, you infer, you predict. Usually you're using someone else's data. Usually you're using someone else's data. And you can predict. Let me give you an example. Let's say I go to the DOT. I go to DOT and I pull up records for the last 10 years of drunk driving and how many innocent people have been killed by drunk driving. Not the drunk driver, but how many people besides the drunk driver, because he or she usually lives because they're drunk. But most of the time, a drunk driver will kill somebody. And I look at the last 10 years, can I predict, maybe with a certain amount of confidence for next year, what will be the death toll by drunk drivers? Yes or no?
Yes.
Yes. And that's called inferential. This is a test question. This is also these questions that I've just gave you with capital S and lowercase statistic and parameter. Those are all ACT questions, TEAS questions, SAT questions, standardized test questions, but these are also on my test. So you got up to 5 questions now because these 2 will be on there also. And I have seen students lobotomized over the definition of descriptive and inferential. And it's not that big a deal. Inferential, you usually are using someone else's data. You could use your own data if you studied drunk drivers for the last 5 years. But, you know, that's where your research comes in with the inferential. You do your research, you find out, you know, how many drunk driving deaths over the last 10 years, and you get all this data up, then you're using your own. But most of the time you're going to use somebody else's. That's my phone going off. I'm sorry. Nobody have a heart attack. All right. So uses someone else's data. Descriptive, find the average age of people in this class. Will that predict next year's class? Probably not. But it probably will, since all 18 and 19-year-olds or 17 and 18-year-olds are in your grade. Okay? So that's kind of a, but what if I take the average age of people at the Dollar General in the pasture out here? If I take the average age of the Dollar General and take it a week from now, are you going to be able to predict? No, because that's descriptive. Everybody got it? All right, let's move on. Now we're going to 2 different areas that a lot of people think they know, but they don't know. And that is qualitative and quantitative. Qualitative and quantitative. And I'll show you how I tell my students to learn qualitative and quantitative. Qualitative. Quantitative. And I don't know if I spelled them right or not. If I didn't, I don't really care. Qualitative. Blondes, brunettes, and redheads. Green eyes, blue eyes, brown eyes. What are those? Somebody tell me what these are. Starts with a C.
Characteristics.
I'm sorry, speak up.
Characteristics.
Characteristics, exactly. They are characteristics. Write that down. That's your key word. Characteristics. Quantitative data is characteristics. Quantitative data is characteristics. Now I'm going to give you 3 examples of questions that they may ask you on a test. Zip code, area code, and social security number. What is the area code, the zip code, and social security numbers? That means I want somebody to take a guess. You need to speak up. I can't hear. Whisper.
Zip code is 21655.
No, like that.
What was said? I'm sorry, I missed it.
Nothing. Nothing's funny.
Okay. I asked y'all if y'all were going to be able to handle this.
Raleigh said something stupid.
Okay, are we really into stupid or what?
Yeah, Raleigh said something stupid.
Okay, well, let's not do stupid. I asked y'all, I said, can we handle this? And y'all said we could handle this. All right. Zip code, area code, and social security numbers are all what? Qualitative. I'll tell you something you can ask yourself to find out if it's qualitative or not. The average of blank is, okay, what is the average of blonde? What is the average of area code?
There is none.
Can't do it. If you can't do it, that means it's quantitative. What's the average of brown eyes? But what's the average age? What's the average height? What's the average weight? What's the average shoe size? These are all quantitative data because they have mathematical meaning. You can ask yourself, what is the average blank? Can you say what is the average age? Yes. Can you say what is the average height or shoe size? Yes. Would you believe that people, is everything okay back there in the back?
Yeah, we're good. We're good.
Is everything okay?
Yes, sir.
Okay, because I see people turned around and that you're not listening. Okay, what is the average age? Okay, so that is the 2 definitions of qualitative and quantitative. 2 easy questions. I don't get 10 people miss this, I might get 5 people miss it. Any questions on qualitative and quantitative? Now, another test question. Discrete and continuous. I'm going to give you some keywords that you can remember for these words. You ready? For discrete, concrete, locatable, predictable, pattern, and countable. And rational. I'm going to give you some examples of discrete numbers. 1/3, 4 divided by 2, -6, and 2/3. Those are all discrete numbers. Looks like I got a question. I don't know if that was an old question or a new question. Or somebody's just talking, one of the two. Oh, okay. Okay. Continuous is the opposite. Not locatable. Not predictable. No pattern. And irrational. And instead of counted, everything continuous is what? Measured. Now I want everybody, if you got a calculator, get out a calculator. And most of you got one on your phone. Just flip it to the side and use the scientific if you got a phone. Okay? And I'm going to take mine. And I don't know if they fixed it yet or not. So I'll use, I got 3 different calculators I can use. And I'm waiting. And so I'll go to this one. So here's the calculator, and I'm going to do one of the rationals. As soon as it comes up, eventually, there it is. So I'm going to take 1 divided by 3. Somebody tell me what that next digit is. What's the next digit?
3.
3. So did you just predict the next digit is 3? Yes. If you can predict the next digit or the next series of digits, or you see a pattern, then it is discrete. How about 2 divided by 3? 2 divided by 3. Now erase that 7. What's the next digit?
6.
6. That is discrete. 4 divided by 2. Does everybody know what the next digit is? Yes, 0. 0.0000. It's predictable. That is discrete. Well, what's not discrete? What's continuous? All right, somebody type in the square root of 2. Somebody tell me what's after the 2. Just by looking at it. What's after the 2? The 2 on the end there.
1.
2.
You have no idea.
We don't know.
Because you have no what? You have no pattern.
Pattern.
Does anybody see a pattern here?
I do not.
So if you don't see a pattern, that means it's continuous. How about the square root of 7? How about pi?
2, 1, 1, 3, 4.
Can you see a pattern? No. So if you cannot see a pattern, that means it is continuous. And I bet you a bottom dollar, one of y'all out there, or 2 of you, didn't know the difference between rational and irrational. Now you know. Rational is a pattern. It's locatable. It's countable. Irrational is not countable. It's not a pattern. What about eggs? What if I asked you on a test, what is eggs? Is eggs continuous or is it discrete?
Discrete.
Because you count eggs. What about a gallon of milk? A gallon of milk is measured because it is volume. I need you to write down the following things: meters, liters, and grams. Somebody tell me what meters represent. What is that noise I keep hearing? I'm sorry, say again.
We don't know.
It keeps sounding, it sounds like, I don't know, it sounds like garbledy. Okay. What does meters represent?
Distance.
Length, distance. What does liters represent?
Volume.
Volume, good. And what does grams represent?
Mass.
So tell me what is going to be mostly continuous: length, volume, and what? Weight. And that's the difference between continuous and discrete. It's really not that big of a deal, is it? But you would be surprised on how many teachers can screw that up as far as explaining it. And you can go to your book, qualitative or categorical variable. Oh, that's qualitative. Where's the, there we go. A discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. The term countable means that the values result from counting, such as 0, 1, 2, and 3, and so on. A discrete variable cannot take on every possible value between any 2 possible values. Continuous is a quantitative variable that has an infinite number of possible values that are not countable. A continuous variable may take on every positive value between 2 values. I'm sorry, but I'll go with my definition. Here's some examples. The number of heads of flipping a coin. The number of cars that arrive at McDonald's. The distance that a Prius can travel. And of course, you see discrete, and continuous. Bless you. That's
Thank you.
one. 2 more times, I throw you out. Now, I'm going to go ahead and give you these orders of measurement. I want you to write them down. I will not test you on them, but they will be on a standardized test, so you might want to write them down. The first one is called nominal. I'm sorry, I keep hitting the wrong button. Nominal. Nominal is an umbrella. Everything falls under nominal, everything. Whether it's the number of males versus females in the room, or the number of people that are wearing flip-flops. It doesn't matter. Nominal covers everything. So you might want to write that down. Nominal covers everything. All you got to write down for ordinal is order. It's got to be ranked in some kind of order. So you're talking about race results, or you're talking about, you know, what are the best bands in the last 50 years? That's ranked. Anything in order, that's ranked. That's ordinal. Interval. I wish I quit hitting the wrong buttons. Interval means that there's an interval. Interval would be like temperature. If I add 10 degrees to 10 degrees, am I going to get 20 degrees? Yes.
Yes.
Ratio. Oral ratio. Remember that the ratio is a variable of 0 means absence. Let me ask you a question. If we're counting the number of days you study for a test, and one person has 3 days, one person has 4 days, and one person has 0 days, does that 0 mean that you didn't study at all? If you're studying for a test and you're counting the days that you studied for the test, if you put 0 down, that means you didn't study, right? So 0 means the absence of studying. 0 days. So that means that the days you studied for a test, that would be ratio level. And that's page, I don't know what page that is. Let me look again. That's page 10. And here is the examples. If you want to write those examples down. And I'm just going to go right there and show you. Gender is nominal. Temperature is interval. Number of days that you studied is ratio. And the grade that you make in class, that's ordinal. Questions so far? Now, again, I want you to write that down because that is a question that would be on a standardized test. I usually don't test you on measurements. And that's 1.1. So right now, you are responsible for 1.1 homework. Let's go to 1.2. 1.2. What's the difference between an observational study and a experiment? Well, that's pretty simple. Can somebody tell me what you do during an observational study?
You observe the participants.
You observe. So you ever watch people watch, like go to the mall and people watch people, or you would just watch people? And you know, some people do that. That's fun for them, especially some nights when all the crazy people are out. You know, just watch and see what happens. You ever gone to a Walmart parking lot on 2 o'clock in the morning on Friday night or Saturday morning?
Yes.
That's interesting. That's observational. You're just sitting there and you're watching. How about a rat in a maze? That's observational. Some people would argue that the maze is an experiment, but no, you're watching and you're timing the rat as he's going through the maze, or the mouse, or whatever you want to call it. You're timing him, so you're just watching. Now, let's say you put a piece of cheese in each corner of the maze. What has your observation become?
An experiment.
An experiment. Write that down. As soon as you interject something into an observation, it becomes an experiment. Let's say that every time the mouse got near a opening, you shocked it with a bolt of electricity. That is an experiment. You may get a question like this. Make sure you know the definition. An observation versus an experiment. Does the flu shot benefit seniors? Only if you give them $100. I'm sorry, I shouldn't have said that. All right, so let's just forget that. Lurking variable. I like to talk about a lurking variable, but a lurking variable is something that influences an experiment or research that you didn't think about. I'm just going to give you an example of a lurking variable. It's not considered. All right, now I want you to watch what I draw up here, because I'm going to say that I've been studying drownings at Lake Hartwell and cases of Rocky Mountain spotted fever. And I have found that there is a correlation between the two drownings at Lake Hartwell and cases of Rocky Mountain spotted fever. But one has to do with water and one has to do with land. How are these two tied together? I'm asking y'all, how are these two tied together?
Warm weather.
How did you know that?
I'm just good like that.
Are you just gifted and talented? Is that what it is? Warm weather months is a lurking variable. It's something that when you're talking about an experiment or research and you've got two things that have something in common, usually that is something you haven't considered. This is a lurking variable, something that is not considered. Question, gripe, complaint. That's a lurking variable. I wish there was something I could do to help out with making these definitions a little bit less boring, but there's not really anything I can do about that because that's why they're definitions. I'm sorry. So I just pray that you'll, bear with me, okay? Census, I need you to write down census. This is a standardized test question. A census is a list of all individuals in a population along with certain characteristics of each individual. This was talked about last year. Do you remember? The census. What was talked about last year about the census? Whether or not something was to be put on the census. Anybody know?
Race.
Not race. I'm sorry, somebody said it. Say it, what? Starts with a C.
Citizenship.
Citizenship. And there was a big talk about what should be, on the census of the nation. Should that be on there? That's something you ought to think about. Should it be on there or not? I don't ask questions on my test about census, but it will be a standardized question. Y'all just have to bear with me. I'm going as fast and slow as I can at the same time. And that's 1.2. Usually I cover these sections. Actually, if you want to know the truth about it, you could put all this in one section. I don't know why this book is broken up into 5 sections. But that's the way they do things. This is a test question, random sample. It's also a standardized test question. Can anybody give me 2 words to define a random sample? 2 words. Anybody? Here's your 2 words. Equal chance. Equal chance. That's the only 2 words that you have to look for in a definition for random sample. If I give each one of you, I'm going to start again because I'm going to start again. If I give each one of you a yellow Post-it note, I'll start again. Well, hell, why don't I just let y'all talk and then I'll talk whenever y'all are not talking? All right. If I give each one of you a Post-it note and I tell you to write your name on that Post-it note and I put it in a punch bowl, that is a random sample because everybody has the what?
The same chance.
equal chance of being picked. But what if one person takes the yellow Post-it note and uses a pink Post-it note? Does that change anything? Yeah, it changes a lot. So when you're talking about a random sample, you're talking about two things: equal chance and uniformity. So you don't have any form of what? So you don't have any form of what? Bias. And there is a whole section, 1.5 is on bias. I didn't write the book, so don't fuss at me and tell my department head that I wanted to talk about bias. That's in the book, okay? I had somebody last semester say, all he wanted to talk about was bias. Well, yeah, it is. It's a section in the book. All right? But bias. What is bias? It's when you can read that in 1.5. Okay? Equal chance. If you change your yellow Post-it note to a pink Post-it note, unless the person that's pulling the name has a blindfold, what are they going to say about that pink? When they reach in to the bowl, they're either going to do one of two things about that pink paper. What are they going to do if they're reaching around and they can see that pink paper? They're going to do one of two things. What are they going to do?
Not grab a pink one or grab a pink one.
They're going to stay away from it as far as picking it, or they're going to go right to it and pick it. So that changes what? That changes the equal part. So all the research, all the questions that you send out on your surveys, everything has to be uniform and non-biased. It has to be right down the middle. Does anybody know what the enemy of a good statistician is? Bias. That will that will ruin a person's career. All right, so a random sample. Now, why am I spending so much time on a random sample? Because that's what you want in statistics. You want a random sample. This is what you want. Now, there is an alternative. There's two alternatives to a random sample. A simple random sample. Now, there are some books that do not consider this a simple random sample. Equal chance, but not as an individual, but as a what? Group. Let's say I pick the first three people in the room, going across the room, and I call that Group A, and I put Group A and their names on a Post-it note, yellow Post-it note, call it Group A, and I put it in the punch bowl. The next three people, I call them Group B and put their names on Group B, and I put it in the Post-it note. Then I take the people that are calling from home, I put their names, call them Group C, and the people on the back row, I'll call them Group D and put their names on it. So what's the difference in a random sample and a simple random sample. A simple random sample is usually done with a group. Everybody with me? So I've got group A, group B, group C, and group D. And I put that Post-it note and that Post-it note and that Post-it note and that Post-it note in a bowl, and I pick one of those. That is a simple random sample. And then the last one, systematic. A systematic random sample is where I pick every nth and follow that same what? Pattern. So let's say I send you outside the door of the classroom and I tell you to pick every second person and ask them if they like the color yellow. Okay? Then that would be a systematic random sample. Every nth person, every second person. And that is a systematic random sample. I will test you on these three. I, meaning me as a teacher, I will test you on systematic, simple random, and random. But there's three others that you need to learn for other tests, standardized tests. And that is cluster, stratified, and convenience. And here is stratified. Well, let me see if that's stratified. No, that's simple. We done talked about that. Well, I thought stratified were in there.
It's page 30.
Page what?
30.
30? Heck no. I didn't know it was that far. Oh, it goes into the next section. Stratified. I would put, if I was you, I would put, if I went through and I surveyed all the elementary schools in District 5. So you might want to write that down. All the elementary schools in District 5. What do they have in common? Well, they're all the same age, right? Unless you got some 22-year-old in the 6th grade, 5th grade. You got all the same age. So they have something in common. They're similar. Stratified means that you've got similar people, some way, some form. Where a cluster is not similar. Let me get the, what about a voting precinct? Does a voting precinct, does those people have anything in common? Not really, because you can vote when you're 18 up until you did. Okay, so their age is not the same. Their gender is not the same. Their race is not the same. Okay? Whereas with surveying all the elementary schools in Anderson County, or all the elementary schools in District 5, all of them are the same ages. Everybody with me? That's the difference between stratified and a cluster. And then a convenience. Convenience is the least accurate. Make sure you write that down. Convenience is the least accurate. soon as I can find it. There's a cluster. And there's a convenience. And look what it says right beside it. It says convenience sample sucks. That's what it says. Let's say I worked at a rock station. Let's say that I was a DJ at a rock station, and I've basically been working there for 5 or 6 years, and I decide I'm going to take a statistics class, and I have a project, and I've got to survey at least 100 people about something. So I sit there and I think about it, and I get out on the air, and I say, I want everybody to call in, the first 100 callers, and tell me, what kind of music do you like? Well, what's wrong with that?
You're on a rock station, so it would most likely be rock.
Okay, the convenience sample is the least accurate because of that one thing. It's convenient. Y'all ever heard of somebody telling you that nothing is free?
Yeah.
Okay, that's a very true statement. How many of you have played either in the band or an athletic team? If you practice, you get good. If you don't practice, you suck. Period. I don't care how good you think you are. If you don't get in the weight room, you're going to suck as a lineman. All right? If you don't study, I don't know anything about musical instruments, but if you don't study how to play the saxophone, you're going to suck at it. Same thing with math, same thing. You get out of it what you put into it. Same thing with research. If you go out there and do a convenience sample, you're probably going to fail the research project, or you're going to get fired, because the convenience sample is the worst one to use. Darn, I didn't turn my video on. I'm sorry. I apologize. I thought I had my video on. Okay? I apologize. I suck.
That's all right.
That's all right. Y'all should have said something.
You weren't sure if you wanted to or not.
No, I don't want anybody to see me. That's why I'm going to put, I got issues, so I'm going to put smokestacks on my pickup truck. Shut up, Hubert. You shouldn't say things like that. All right. Next. I tell you what. Let's see what's next. I don't want to go too far. Let me see if I can get. Yeah, I can get to 1.5. 1.5 is bias.
That was the systematic stuff.
What are y'all talking about?
1.4.
1.4, yeah.
There we go. I want you to write down bias. And I want everybody to witness this, that it is on page, whatever page it's on. I can't find it now. But anyway, it's on page. I can't get my computer to work. On page 38. Now, why is that word so famous right now? I mean, I just talked about it one time last semester and I got complaints. Okay? I don't know how you can complain about something that's written in the book. What is bias? When you're trying to push your own what? Agenda. Write that down. Pushing your own agenda. Can anybody give me the famous quote by Mark Twain about statistics?
I can't say that. Just say, I'm not saying it.
Oh, yeah.
But what do you say?
Mark Twain and statistics. I have to pull this up because people think I'm making it up. What did Mark Twain say about statistics? There are lies, damn lies, and statistics. Now, does that mean that he hates all statistics? No. It means that people can turn and distort statistics for their own agenda. And that's basically what bias is. Now, bias can be done two different ways. And I'm going to stop after this because I think my time's running out and some of y'all are going to start convulsing on the floor. So, bias, especially that back row back there, I'm worried they may go into hysterics if I don't settle down soon. Bias. Bias can be by mistake, or it can be by what? Intentional. Okay? Bias can be by mistake, and it can be intentional. And I will give you a quick example of by mistake. Let's say that you work at a newspaper and you have just done a story on the price of fuel in the last year. And you have found that the price of fuel in the last year is up 150%. And you write a story and you write it real pretty and you send it down to graphics. And you send your story, here's your story, and you send it to graphics. And there's a guy that works in graphics that don't know his rear end from a hole in the ground, and he puts up a big barrel of OIL and a little barrel of OIL, and this one's like 50 times bigger than this one. Is that going to go with your story? Yes or no? No. And that's when something is done by accident. And I don't think we have to go over intentional. Can anybody give me an example of intentional bias? Anybody? Nobody? Nobody can give me a case of intentional bias. There must not be any Clemson fans, because whenever Clemson is losing, whose fault is it?
The referees.
The ref.
Exactly. With a Clemson fan, I'm talking about a crazy Clemson fan, not just a regular. I'm a regular Clemson fan, and when they are getting beat, they're getting their butts beat, okay? But a crazy Clemson fan will blame the referees first, then they'll blame the, is everybody listening?
Yes, sir. Are we listening?
They'll blame the commentators next, then they'll blame the stadium, then they'll blame the grass. Okay?
The grass is not fixing the different things. There's just not the grass.
Intentional bias, you have to look for. Intentional bias, you have to look for. And I'm gonna let you think on that. And we're going to stop right now because I got to call the roll, and this is going to be hard to do. Now, first of all, let me say this. What section am I on right now?
1.5.
So that means between now and Thursday, you should have either 1.1 through 1.5 finished, or you should have sent me some questions on each section. I will put a date on 1.5 material, 1.1 through 1.5, and it will be close to Wednesday or Thursday. Okay? So you better get started on it. I'm fixing to turn off the recording. and I'm fixing their definitions, people.